Okay, 7.5. I know I keep saying it's super easy, but it really is. You're gonna draw this graph, okay? This is like algebra 1, right? Yeah? Super easy. So you just need to remember how to draw a line, right? 2x plus 3. Remember how to draw 2x plus 3. I guess the real challenge is remembering when do you need a solid line, when do you need a dotted line, okay? So just reminder if you have greater than or equal to, or any kind of equal to, you put solid line. If you just have greater than or less than, you have dotted line. And just a reminder on how to shade. Greater than or equal to, you shade up. Less than or equal to, you shade down. So just a reminder, but you probably already know. All right, go ahead and graph this, shade it, and answer the question. Is 4 part of the solution? Okay, so we're gonna start at 3, and it goes up 2 over 1. Draw a straight line and solid because it's greater than or equal to. We're gonna shade up because it's greater than. And the question is 4 part of the answer? Obviously, no. How would you be able to solve this algebraically without graphing? Plug it in. Yeah, just plug it in. So y is 4, x is also 4. So just check, does it make sense? 4 is greater than or equal to 11, does not make sense, so no. All right, easy. Okay, just a vocab. Boundary means the line that divides the region. Meaning you have a shaded part, you have a non-shaded part, so that line that divides them is called a boundary line. Let's practice this. Okay, so this is a little more complicated because you just learned this last year. This is a parabola and a normal parabola with a transformation. Pretty easy. Make sure you use the correct kind of line and correct shading. Let me know when you're done. Okay, this is a normal parabola, but moved down 3. So we're going to start at 3 and negative 3, sorry, and then it goes 1, 1 like that, and then 2, 4. Points up. The shading is up, so it's going to be inside. All right, I'm going to show you how to do this on your calculator. Your calculator does shade for you. I almost never use it because it's faster to think about the shade than to use the calculator. But I just want to show you where it is, so if you want to use it, you could. Okay, so everyone take out your calculator. What you're going to do is just type that in first, and then I'll show you what to do with the shade. So type that into your calculator like you were just going to graph it. Like you were just going to graph a parabola. Okay, once you type it in, this is probably, you didn't even notice that it existed before. So your cursor is on probably here once you finish typing, right? So what you don't notice is on the left, there is this line here, right? On the left of y, 1. So what you're going to do is go to this point, this part. So just scroll all the way to the left. And then what you're going to do is press enter. And then you're going to press enter until you see that it changes like this. This means shade up. Okay, so it's a triangle that is shaded. Yeah, and then when you go through the option, you know, you can try different options. Like, for example, the first one where it looks like this means graph it with a thick line. And then the one that goes like this is please shade up. And this means shade down, so less than. I think this means graph everything with like a circle instead of a line. I don't know. I don't know what the difference is. You have to kind of like check it. This means dotted line. So instead of solid line, they give you dotted line, a really dotted line, and then it goes back to the original. So you're gonna choose the one that shades up and then graph it. I think the ones with color look better. If your calculator is not the one with the color, then it just kind of looks like you have a bunch of lines. Yeah. Okay, that was just a calculator practice. Let us go to the next one. So you're gonna solve this graphically. Solving it just means graph it. Okay, you can use a graphing calculator to check, but basically graph these two. Make sure you use dotted line and not solid line. First one, y greater than x squared. So it's gonna be this, oops, this one. And we are gonna shade up. The second one, I can find the x-intercept and y-intercept. X-intercept is at 2. Y-intercept is 4/3, so that's 1 1/3. Looks like that. This one we're gonna shade down, because it's less than. So the region that they share is that part, the green part. Green part is the answer. Okay, we're gonna do one last practice, and then tomorrow we solve some word problems, which is still just review from Algebra 2, the linear programming stuff. Okay. This one. Now you have 4 lines. I don't know if you remember this from last year, but this x greater than equal to 0 and y greater than equal to 0, yeah, it just means the first quadrant. Okay, so go ahead and graph this. Let me know when you're done. Okay, so again, this part, this part just means quadrant 1. And then what we want to do is just graph the other one. This one, the equation is not in y equals mx plus b. Sometimes it's just easier if you graph the x-intercept and y-intercept. So again, make y 0, make x 0, and then solve that. So first line looks like that. We're gonna shade down this way. Second line is x-intercept is 7, y-intercept is 14/3. 14/3 is a little more than 4. And then shade down. And then we are in the first quadrant only, so this area. Okay, do you guys still remember this from Algebra 2? Yes. Okay, all right, so tomorrow is going to be pretty much exact same thing as last year. Just a little harder problem.